Okay, so what we're looking at here is we're looking at the ball colliding with the floor. So our system here is the ball. The environment here is the floor, and we're looking at that really short interaction it has with the floor. So we're looking at the ball right the instant before it hits the floor, and then the instant at which it's rebounding back up to a specific height. So in trying to determine how high this goes, we're going to need to know the speed right after it collides with the floor. That being said, we do need to find out the speed right before it hits the floor. So if we let's call down negative and up positive. So initially we're going to have momentum that is headed down. Then we know this is going to bounce up with a positive momentum, which means the floor is going to have to exert an impulse to change that momentum from a -2 to a +1 of some amount. All right, so the impulse here conceptually is going to be +3. Now, these are just arbitrary units. They're more for conceptual in nature. So we're going to look at this. So the equation we're going to need is the mass times velocity right before it hits the floor plus the impulse while it's hitting the floor. So this will be the floor on the ball times the change in time is equal to the final momentum. Now, because our impulse here, the floor is not a constant force, this equation doesn't apply. So we're going to have to go to our graph here and find the area of this graph to find the impulse. All right, so to figure out the speed right before it hits the ground, we can use our motion expressions here, where we initially have our initial height is 40 meters. Our acceleration is -10. Our final height here would be 0. Our final velocity we don't know. Our initial velocity is 0, and the time we don't know. It takes the fall. But using the v squared expression, okay, we can find our final velocity to be the square root of 2 times -10 times -40. All right, we find that final velocity. This is going to be 28.2 meters per second. So we know the mass of the ball. To find the impulse exerted, all right, we can find the area of this. So the area of that is going to be 1/2 times 480 newtons times 10 milliseconds, which is 10 times 10 to the -3rd seconds. So when we calculate this, our impulse is going to be 2.4 Newton seconds. So we can figure out what our final speed is, and then we can use our motion equations to figure out how high it goes. So that being said, we have our mass is 0.06 kilograms times the initial speed, which is -28.2 meters per second. I'm calling down negative here, as I set up in my problem here. The impulse exerted upwards is 2.4 Newton seconds, and that will equal the final mass times that, or sorry, not the final mass, the final velocity times the mass of the ball. So we're going to get -1.692 plus 2.4 is equal to 0.06 kilograms times our final velocity. Our final velocity, when we calculate this, is 11.8 meters per second directed upwards. So if we are now trying to calculate how high this goes, again, we can set up our motion. We have our initial velocity is 11.8 meters per second going up. Our acceleration is -10 meters per second squared. Our final velocity is 0, and our change in height we can solve for. Again, we can actually do this using the v squared equation. So we have v squared is equal to the initial velocity squared plus 2a delta y. And solving for delta y, we have v squared minus v initial squared all over 2a. Solving for delta y, we get approximately 7 meters high. Or I think the actual number would have been 6.96 meters high. So the impulse is really, if you just notice, there's the bell. The impulse is really just what happens as the ball collides with the ground. We are looking for the instant right before and right after that collision.